Hello students, and welcome to our first lesson in the second topic on Unit 1. So the next topic we're going to look at is measurement. And the first lesson we're going to look at is Pythagoras' theorem. So the point of today's lesson is to review Pythagoras' theorem and to use it to solve practical problems in 2 dimensions and simple applications in 3 dimensions. So Pythagoras' theorem works with right-angled triangles, and we're going to look at 3 different strategies to either find the sides or the angles of right-angled triangles in Unit 1, and they include Pythagoras' theorem, similar triangles, and trigonometry. Now, Pythagoras' theorem relies on knowing the length of 2 sides to find the length of the third side of a right-angled triangle. So you will be familiar with Pythagoras' theorem. You probably heard it as c squared equals a squared plus b squared. But if we were to write this out, we say it as the square of the hypotenuse is equal to the sum of the square of the sides. Now, if we have a look at what that means, if we have a triangle down here on the left-hand side, and you can see that we've got a side here of 4 squared, we've got a side here of 3. If I say, well, 4 squared, that's going to be 16. And if I say 3 squared, that's going to be 9. Now, if I add 16 and 9 together, I'll get 25. So to find out the length of the longest side, or the hypotenuse of a right-angled triangle, all I need to do is to take the square root of the sum of those 2 sides. So the square root of 25 in this case should equal 5. And you can see that 1, 2, 3, 4, 5, and that makes sense. Now we're going to note that we can rearrange the formula. So we can just say that hypotenuse, or side C, is equal to the square root of a squared plus b squared. And you can also conclude that the hypotenuse squared minus one side squared equals the length of the other side squared. Now, if I have a look at a worked example, so if we want to determine if something is a right-angled triangle, we can see that I've got 3 sides here, and for it to be a right-angled triangle, it needs to fulfill Pythagoras' theorem. So the sum of the square of the sides is equal to the square of the hypotenuse. So does 15 squared and 20 squared equal 30 squared? Well, let's have a look. 15 squared, 225, 20 squared is 400, and 30 squared is 900. So 600 does not equal 900. So this is it is not a right-angled triangle. Now, we should note then that with obtuse triangles, that means that this angle is greater than 90 degrees. That the sum of the square of the sides is going to be not as large as the square of the hypotenuse, or that the sum of the square of the sides is going to be smaller than the square of the hypotenuse. And acute triangles, that means, for example, this one's going to be less than 90 degrees, it's going to be the opposite. So acute angles have all angles less than 90 degrees, so the sum of the square of the sides is less than the square of the hypotenuse. So 3, 4, 5 is a very common example given for Pythagoras' theorem, and there's a whole family of triads, that is any 3 numbers that fit this pattern. So 3, 4, 5, if I double those to 6, 8 and 10, that would fulfill the criteria of Pythagoras' theorem, and that will work. Likewise, if I multiply them all by 3, so 9, 12 and 15, yes, they belong to Pythagoras' theorem, and that's a family of triads then. So if we look at another example of a triad is 4, 5, 6, a Pythagorean triad. So in this case we haven't drawn the triangle. So 4 squared is 16 plus 5 squared is 25. Does that equal 6 squared, which is 36? No. Well, 16 and 25 is 41. and that's not the same as 36. So that's not a Pythagorean triad. Now let's have a look at a three-dimensional example of Pythagoras theorem. So we want to think about what is the longest straw that could fit into this box. So we're going to have to go from the bottom corner to maybe the bottom left to the top right corner. And so let's have a look at that. We're going to have to determine, first of all, the hypotenuse along the bottom. So we've got a right angled triangle down here at the bottom. So with one side is 15 centimeters, the other is 20 centimeters. And let's have a look. We've got another line, and we need to go from the hypotenuse across now from one corner up to the next corner. So we're going to have to apply this Pythagoras' theorem twice. So when we formulate our plan, we know that h squared equals the square root of side A and B squared. So let's solve that. So we're going to look at the bottom triangle. So we need to consider, well, what's 15 squared and 20 squared? Well, we know that 15 squared is 225 and 20 squared is 400. That'll add to give 625. The square root of 625 is 25. So we know the bottom one now is 25 centimeters. Now we need to do another triangle from along here, assuming that's a right angle. So we're going to say 25 squared, and we're going to go up 10 squared and find the hypotenuse from that. So that'll be 26.95 centimeters. So we can now just communicate answering the question. We can now determine that the longest straw that would fit in the box is going to be thereabouts, close enough to 27 centimeters. Now we can reapply that formula, and the formula for determining the internal diagonal of a triangular prism, for example, is just going to be a reworking of Pythagoras' theorem, and you can see that here, that AF squared, so that's this line here, equals AC squared, so that's this line here, and CH squared, which is this one here. Oh, sorry, CF that should be. So let's put an F there, as I've said there. And that's another way to work Pythagoras' theorem for a 3D shape.